Did somebody say Papa John? Alright, so let me get everybody's full attention. I have started recording at this time, so I do need your full attention. First of all, the answer was A, so if you got it A, pat yourself on the back. You're able to perform the formula and do your calculations in your calculator correctly. Just to remind you, these are at equilibrium conditions, so you did not need an ice table here. All you needed to do was the products over the reactants. You've got to remember that for equilibrium, which meant NH3 squared over H2, bless you, third to the third power, and then N2 to the first power. And then you just plug in the numbers.
Oh, okay.
So it would be for ammonia, they did it by name here, which we're going to talk about in today's lesson. You do have to know ammonia by name. Ammonia is NH3, so that will be 4,000 squared for the top. H2 would be 8,000 cubed, and then this would be 7,000 for the amount of nitrogen to the first power.
And you multiply the H2 and nitrogen, right?
Correct. So just like this. Answer was A, if you are able to do this correctly. Yes, multiply. Make sure you write that down. It's really important for the formula that you get it correct. So, what are we doing today? What's going on? First of all, quarterly exams. I went straight home and graded them. Like, literally. I did tutoring. I went home at 4:30, and I marathoned that day. I noticed you all did overall quite well. I was coloringly impressed. 90% pass rate, and a lot of C levels, which is where I had said 100% at. So very nice job to all of you who studied hard and are working through it. Because the thing about these quarterly exams is they're to help make sure you study throughout the year, so that you're not just staying the day before. You should, in no world, be on Wednesday, May 14th, starting to study. Because if you are starting to study on May 14th, it's probably over for you. I'm just going to be honest. The way to do well is to consistently practice throughout the year. And you'll notice I put probably the most that I can into this class right here, because I know this is the most curriculum. I know it's the most material. That's why you've got the most tutoring. You should notice your class has the most tutoring. I teach 3 crafts of chemistry. I teach 105 students in pre, 18 students in AS, and 10 students in A. And you guys have 3 times the amount of tutoring that everybody else has because of how intense this course is. And so far, you've all been doing quite well. I'm proud of you. Keep it up. This next month is super important. How well you do in this next month will determine how well you end up doing on your exam for the most part. So make sure that you are attending reviews as much as you can, that you're practicing as much as you can, and hopefully you will guarantee yourself a passing score that way. Let's talk about your course grade, and let's talk about what I posted on Google Classroom earlier today. I was I made a couple of arrangements to tutoring that I think is overall in your benefit. I noticed when I checked grades yesterday during the teacher planning day that 3 people out of 18 turned in the homework on Tuesday night. That was due. The homework too. And so, I didn't check the other. I don't know. I think I only checked one of them, not both of them. But I haven't put in those grades in the grade book. But I checked it, and I was like, okay, let me extend this and give some more time. A couple people sent me some messages that, Miss, I don't know how to do this, or please help. And so I decided to give an additional, because I did have tutoring after school on Tuesday, but I have an additional tutoring today after school. I'm staying for an hour just for all of you to kind of just focus in on those ice tables and equilibrium and making sure you've got that down. So make sure if you need that assistance that you are stayed back after school today. And then on Saturday, we're going to start our actual core content reviews, which we're going to start with Unit 1 and 2. We're going to do those both on Saturday because those are the easiest units. But going through some of your quarterlies, you forgot. Some of you forgot a lot of things from Unit 1 and 2. So we need to go over it. We need to go back over what are the key important things you need to remember. And so that's what Saturday tutoring is going to be about. For AS chemistry, that tutoring starts at 10 a.m. So write that time down. If you're here for English and math, I would like you here for chemistry at 10 a.m. If you're just coming in for ACE tutoring, then get here at 10 a.m. for AS tutoring, because I'm doing A tutoring at 9 a.m. So like if you come in 9 a.m., like that's not gonna be for you. I mean, you could sit here, but it's not gonna be for you. Does that make sense? Yes.
Figures they're gonna put this in just like leave the classroom, ask the teacher.
I think you can. I would double check with, double check with Ms. Kaufman, but I think you can. If anything, if they tell me something different, I'll post it on Google Classroom. Make sure that for this class you are still in Google Classroom, because that's where I'm posting stuff through along with talking points. Yes. That's a great question. There's no formal uniform for Saturday. You can come in jeans, but you must be in school appropriate wear. So like, what that means? School appropriate wear. Nothing inappropriate. Don't wear cut-off shirts and like stuff like that. No bathing suits. No mini skirts. I'm just saying that's what school appropriate means. Like jeans and any t-shirt is fine for Saturday. All right, that was the first thing, was the revision to tutoring. I also expanded next week's tutoring because many of you expressed you need help with Unit 3, which is the moles, stoichiometry, molarity, that section, chemical reactions. So Tuesday of next week, we are doing moles and stoichiometry and concentrations. Next week, Thursday, we're going to do chemical reactions and redox. So that's what the tutoring schedule is for next week. This is what I posted up in Google Classroom. Next week, Saturday, is the most important day to attend. Why? Next week, Saturday, on the 20th. That is your first lab walkthrough, and the only one that's going to take place on a Saturday. I'm going to give a paper next week. I'm going to ask who's going to be able to make it, because I'm only going to set up a lab station if you're going to make it, because it takes me hours. And I mean, I will likely be here till 6 p.m. next Friday setting up for your lab walkthrough. Therefore, you have to let me know if you're actually going to come or not. If you're not going to come, then I spent 30 minutes to an hour setting up something that I didn't have to. So I would love for every single one of you to make it. I want you all to come. But if you're not going to be able to make it, I need to know that as well, because I would like to not spend extra hours on Friday nights. Make sense? All right. But that's super important that you come to that, the lab walkthrough. It's your first experience of actually like feeling the time for our lab, like what that 2 hours is going to feel like. So you need to do it. I super value it, which is why I'm telling you all, try to make it to that. All right, next thing. Quarter 4 course grade. I do this every year for the ACE classes, so you know exactly where your grades are coming from this quarter. First part, classwork homework section, is going to be paper 1 and paper 2 homework assignments, the equilibrium homeworks, the accident-based homework you received today, and paper 3 in-class practicals. Those are all going to fall into your classwork homework section of the grade book this quarter. Projects, you're going to be given a revision project right after this unit is over. And you're each going to get a part of the syllabus that you're going to have a little project on, and that project will go into the project grade this quarter. Quizzes. What's going to go into the quiz spot instead of the paper 1 from before? It is your Unit 7 assessment. So the Unit 7 assessment, the typical test you have, because this is less curriculum than usual in this unit, it's going to go into the quiz part of the grade book. And so that's where that's going. Exams. Paper 2 mock exam 1. Paper 2 mock exam 2. Paper 1 mock exam 1. Paper 1 mock exam 2. And if we can fit it in, a lab math quiz. That's not a guaranteed thing, but I'm trying to fit some time in the schedule to try to do that if I can. Grade thresholds for mock exams. They're revised for the fact that you need to try to do as well as possible. A level is going to still be 120, B level is 105, C level is 95, D level is 85, and E level is still 70 because it's a pass, but it's like a bare minimum pass. And then U means you didn't pass. And that's going to be something under a 70, and I wrote how that goes here. Tutoring unit review sessions. If you attend 2 sessions, any 2 afternoon sessions that I put, which are starting, really next week. Actually, today technically counts as well. If you attend any 2 sessions or the lab walkthrough, I will raise 1 mock exam or the Unit 7 quiz by 20%. 20%. If you attend 4 sessions, there's a lot of sessions I'm offering, or 2 sessions in the lab walkthrough, I'll drop 1 lowest mock exam grade out of those 4, so you can put that in the bank, or raise the grade of 2 mock exams by 20%. By 20%. That's how it works. I always do it like this in the 4th quarter. Because remember, your grade is mainly coming from your mock exam. That means if you fold on a mock exam, your grade is plummeting. So it's either don't fold and have some backup points in the mix. So you guarantee you hopefully don't fold. Is the goal. What? All right, so does this make sense? Do you have any questions about this? Question? That would be, I mean, it says drop 1 lowest mock exam grade, right? So wouldn't that be like the same? Whatever is best in your benefit is how I'll answer. Whatever works to your benefit the most.
And 60.
I mean, if you got 120 A level and you attend all these sessions, yes, I would be putting like 140 in the grade one. The max I've ever put for a student was 160. They earned a 160 on an exam. They also earned the top in the USA score last year.
Oh.
So, you know, it could happen. Anyway, let's get started with the content. I just wanted to make sure you have what's coming up. You know, I'm trying to be as organized as possible. There's a lot of stuff going on, but I will spend a lot of time prepping for your class. I hope you spend at least a fraction of the time that I spend prepping for your class in terms of prepping for your own examinations. And if it's like half the time, that would put you in a really good place. Just to let you know, I spend about 10 hours prepping your class a week, just so you know. And you're one of the 3 courses that I teach. So, FYI, a lot of work goes into this class because I want you all to succeed. All right, let's get started. 2 more lessons left, by the way. I'm excited. Are you excited? 2 more lessons left till we're done, for the most part. Next Wednesday, we're going to do our final lab, which is called qualitative analysis. Starting next class, in our final lesson, we're going to start to see that lab, actually. It's going to creep up in the last lesson. That's going to transition into that lab. Today, though, we are going over acids and bases, which if you took pre-ACE chemistry, I did about 3 lessons on acids and bases last year. I taught you how to calculate pH. I taught you some theories of acids and bases, and I taught you theories of acids and bases. I taught you how to calculate pH and just a few things about acids and bases, understanding the pH scale. Some of that will be necessary today because I'll be reteaching it. The good news is that most of the information in acids and bases in the AS level course is equivalent to what you learned in pre-ACE. It's not really much deeper. I'm also including the section about nitrogen and sulfur. So you may have noticed if you were going through that checklist that I gave you that you didn't know much about the nitrogen and sulfur stuff. We'll be going over that today as well. Monday's class, just so you're aware, is random reactions. Our last lesson is random reactions. And going back over the 5 toxic types as well. All right, so here we go. Acids and bases today. Let's get it. There's a lot of standards here. But if you look through them, some of them you already know. State the names and formula of common acids. So be careful you're exactly following what the objectives say when you're studying for your Cambridge exam. They only need you to memorize hydrochloric acid is HCl. Do you know that already?
Yeah.
Sulfuric acid is H2SO4. Nitric acid is HNO3. And ethanoic acid is CH3COOH. 2 carbons, carboxylic acid, right? You know that? Put check mark if you do, right? Well, then it's not a full check mark. Half a check mark. All right. What about your names of bases? Do you know your common names of bases? It says limited to. Remember, alkali is the same thing as base. Alkali, not alkane. Alkali is the same thing as base. Alkali is limited to sodium hydroxide. Did we know that was NaOH?
Yes.
I hope so. We saw it like a billion times last minute. Potassium hydroxide, KOH. Ammonia, NH3. Maybe. If you remember that, give yourself a check mark. If you don't remember that, well, That goes on
The
your
only
stuff
one
to
I don't
memorize,
remember
right?
is potassium hydroxide.
Describe the Bronsted-Lowry theory. You may or may not recognize this, depending on if you remember it from pre. In the Bronsted-Lowry theory, acids are H plus donors and bases are H plus receivers. That's what the Bronsted-Lowry theory states in the most simplest form. We'll be reviewing that today. If you remember that, put a check mark. I have taught it before in a prior class, but not in the AS class. I'll be teaching it today. Describe strong acids and strong bases as fully dissociated, and weak acids and weak bases as partially dissociated. Did you know that? We'll be going over that today. This actually has to do with equilibrium, so you probably did not really learn that before. I love when Cambridge uses this word, appreciate. Appreciate that water has a pH of 7. Do you appreciate that? Acid solutions have a pH of below 7. Do you appreciate that? And alkaline, which is basic solutions, have a pH of, that's a standard. Bases above 7, acids below 7, neutral equals 7, right? All right. I will hope that's a check mark. Yes. Great question that I was going to bring up in a little bit. But the reason why bases are alkali is because when you have OH minus, it's typically with a group 1 metal or a group 2 metal. And group 1 metals are alkali, group 2 metals are alkaline. So that's why they're called alkalis. Because they're OH minus with some kind of group 1 or group 2 base. Understand neutralization reactions. I'm pretty sure I taught this to you. This is where acid plus base is salt and water. When we went over reactions in Unit 3, we went over this. But we will go over it again today because it's officially in the standards. Acid plus base, it's a double replacement reaction. And that's the stuff with acids and bases we need to know. Now let's talk about the nitrogen standards. Nitrogen is not reactive. You have to explain this based on the fact that it's nonpolar. Nitrogen as a gas is not reactive because it's nonpolar and because it has strong triple bonds. So nitrogen in the atmosphere is extremely unreactive. And we'll be talking about that today, revisiting that. Describe and explain why ammonia is a base. We'll be going over that today. State and explain natural man-made occurrences of nitrogen and their catalytic removal from the exhaust gases of internal combustion engines. Do you remember that equation with the internal combustion reactions where you would take very harmful gases and turn them into less harmful gases in organic part 1? Well, we'll be going back over that today too. Along with how does oxides of nitrogen get made naturally? Yes. Yes, you can. And then these two are kind of new. So I would say that this is how it looks for today. Lots of standards means we're going to move through them pretty quickly. And it's because a lot of this stuff at some point we have at least somewhat covered. Ready? Here we go. So starting with, why are acids and bases here and not somewhere else in the curriculum? Like, why directly after teaching equilibrium am I teaching acids and bases? It turns out because there is an equilibrium associated with some acids and bases. And because I hadn't taught equilibrium until now, I couldn't fully teach you the rest of acids and bases until now. So, the basic definition of acids and bases. The first, I'll say instead. First definition of acids and bases that you learn. This is the one that you would learn in a high school level chemistry course, is the Arrhenius theory. And in this theory, it states that any acid, when placed in water, will produce what type of ion? H+. The most basic definition of an acid is that any substance that releases H+, when placed in water, we classify that as an acid. A base is anything that when placed in water releases OH-. That's classified as a base. And we used this theory to figure out, oh, if I have H in the front of anything, it's going to be an acid. And if I have an OH in the back of anything, it's going to be a base. That's the simplest definition of acid and base that you can run off of, but it's not the full story. This should say Arrhenius. It should say Arrhenius, not Roxazar. Alcohols are not bases. Alcohols do not release OH minus. Where have you seen an alcohol release an OH minus? Tell me what reaction you've seen that in. Let's talk. Alcohols are not bases. What does alcohol break off? H plus only, right? If I were to react this with Na, I would get CHHHCHO, nah. Right? Well, nah. Alcohols are not bases. You may want to write that down. Alcohols, no. Alcohols are not bases.
Are they acids?
Deeper discussion necessary outside of today's lesson. Alcohols are not bases.
Are they acids?
They're strange. They are, it's complicated. Again, outside of today's lesson. But they do not fit this definition. Why? They do not release OH minus when placed in water. If anything was to break off of an alcohol, it would only be the H, not also the oxygen. It's because it's with the carbon, because it's covalent, not ionic. So the reason why is because it's covalent, not ionic. So just to give you reasoning. Because you brought it up, so it's a good point. Alcohols are not bases. The other thing that you should know here, besides basic definition of an acid and a base, is a neutralization reaction. A neutralization reaction is just an acid plus a base gives you salt and water. You have seen this reaction before, I promise you. Let's take a look at the simplest one. HCl plus NaOH. What are the products? NaCl, which is salt, and HOH, which is water. So a neutralization reaction is just a simple double replacement reaction between an acid and a base and follows those rules. Salts are more than just NaCl. It could be any ionic compound. So you could have another reaction that's not NaCl as your product. It's still neutralization if you start with an acid and a base. All right. This is your memorization time, but hopefully you can check mark this that you already have this memorized. Hydrochloric acid is HCl. Nitric acid is HNO3. Sulfuric acid is H2SO4. Ethanoic acid is CH3COOH. It is important to note, and because I'm teaching this at the end of this year, you already know this. The H that breaks off in hydrochloric acid is the first one. Do you agree? The only one there. Nitric acid here, sulfuric acid here, but in ethanoic acid, what is the hydrogen that breaks off? The one at the end. Because it's next to the very electronegative oxygen. And so that's how the ionization in water works out. So good? Bases, you just have to know is OH minus, so you give the name hydroxide at the end for the polyatomic ion. So it's simply just memorize your polyatomic. Remember, you're working on these for the end of the year, right? If you haven't yet committed your polyatomic ions to memory, you should. They're up there. You should work on memorizing them. They can show up anytime. They will show up in next week's lab. All right. You will not. And it won't be there. All right, let's do our first checkup. Beforehand, real quick, notice that ammonia is also a base. Do you want to put a question mark there? Why might you question that? Or are you good with that? You're like, yeah, I know ammonia is a base. I'm good with that. Or might you question that? I mean, if you look at your first definition, acid H plus, base OH minus. I don't know you, but I don't see OH minus there. So second question mark?
Same period. It's 13 courses.
Third question mark? So we're going to return to this very shortly, right? We have to explain why ammonia is a base. We'll return to that shortly. But first, how does each of these compounds dissociate in water? Do you remember how to write a dissociation? Potassium hydroxide. What is it? Show how it breaks apart in water. So that's what dissociation is. What would it break apart to become?
K plus OH.
K plus what?
OH minus.
K plus AQ. Because it's in water, right? And OH minus
AQ.
AQ. What is that saying? When you have potassium hydroxide in water, it exists as the ions separated from each other. It dissolves and you get this. How could we test for K plus in water? This is where we're going next week. I'm just bringing it up. Flame test. Potassium's purple. OH minus you could get from a pH, right? Because it's a base and you can measure the pH of that. So you can figure out what ions you have via methods. We'll be going over those in the last couple of lessons. And in next week's lab, that's where a lot of our focus is going to go for the final part of this course. All right, second one. Yes. The path is available. Yeah, it's available. Okay. The green string is there. Nitric acid. So is Cambridge going to expect you? They're going to say the words nitric acid, and they totally expect you to know what that formula is off the top of your head? Absolutely. HNO3, AQ, and now what?
A plus AQ and NO3 minus AQ.
How did you know that? It's correct. Because you remembered NO3 is a polyatomic ion, and H plus, yes, it's nitrates. Just keep repeating it to yourself over and over again. And H plus, well, that's the H that's breaking off, right? So it breaks off positive ions first, second part is the negative ion. Next week, you're going to learn a method to figure out how you have nitrates in an unknown. Next week, coming soon. You will have ways, methods. It's your final lab, is to figure out like what you have in a solution. All right, next. Can you do the reaction between sodium hydroxide, balanced equation, and nitric acid? Could you do that, Marianne? As soon as the person out comes back. NaOH plus HNO3 become what?
Sodium nitrate.
Which is NaNO3 and
H water.
water. Perfect. State of water is?
Liquid.
If you write H2OAQ, that'll tell you what's going on. You write what? Like, you can't write H2OAQ. Write H2O liquid.
Technically right.
It's not.
Like if you split just a little bit.
It's not. Water's not included in an equilibrium expression, FYI, because it's in a liquid phase.
Oh yeah.
It matters. Reaction in aqueous solution between KOH and HCl. Can we do this one? We can't.
KLA.
So it would be KCl and H2O.
Are we good with this?
That's gives me more questions.
What standard reaction type is this again?
Substitution.
I mean, double technically.
Oh, double
But it's called double replacement. Because this was before we learned organic and those other synonyms. And it's that AB plus CD goes to AD and CD. But it's the outer two parts and the inner two parts go together, right? Just standard. Next week when we cover random reactions, we're going to look at reactions that fit this together and then ones that don't. Continue?
Yes.
So why do we call these neutralizations before continuing? Why do we call these neutralizations?
That's why big new questions, right?
Why?
Now they're needed basic force.
Right. You've neutralized your strong acid and your strong
Base.
base and made salt and water. Water neutralizes acid and base. Okay, here we go. Bronsted-Lowry theory. This is the second theory of acids and bases. And this is the one Cambridge will test. There is a third theory of acids and bases that exists. And I'm actually a little surprised Cambridge doesn't have it in the standard. And I wouldn't be surprised if they add it in 2028 when they do their next, which is not a you problem. But there's actually a third acid-base theory. And if you understand it, it makes understanding organic chemistry much easier, by the way. But they don't have it in the standards. Cambridge is going to test this one. A Bronsted-Lowry acid, and so the word Bronsted-Lowry just comes from the scientists who came up with the theory. According to Bronsted-Lowry, any compound that can give away H plus is an acid. The way we say that is that a Bronsted-Lowry acid is a proton donor, and you need to memorize that, or an H plus donor. You could say an H plus donor or a proton donor. Does that make sense that H plus and proton are the same thing?
Yes.
Do you remember that? H plus and proton are the same thing.
Yeah.
Oh. Marinate.
Has
Let it think.
no electrons.
It has no electrons, right? It has no neutrons. Acids are just protons. Yes? So they use this terminology because of that. But if you are uncomfortable with that, you can write H plus donor. Yes? And then a Bronsted-Lowry base is any compound that can accept H plus. So H plus acceptor or receiver. What would make a compound eligible to receive H plus? Think about it. A negative charge, yeah. Because then it'll complex to become neutral, right? A negative and a positive.
Or
But let's take a look at water. Because if you look at this first example, let's expand your brain. And yet this first example here, you're told you have hydrochloric gas and water. Let's give you an idea of what that means. Hydrochloric acid at super high concentrations will have white steamy fumes. And that's something you should know. So it's white steamy fumes. Yeah, it's going to show up next week in the last lesson. When we do random reactions, it'll show up on things you gotta know. So may as well just write it now. HCl is white steamy fumes. So if you breathe that in, you have water in you, don't you? And so this will act as an acid as it dissolves into your respiratory system, and you'll start coughing and hacking and have issues. Not necessarily die, but coughing and hacking and having respiratory ailments. Go ahead, Mariani. So this totally happens. This is when you breathe in HCl. It will go in with water. Not fun. And it should never happen to you. You will not be working with HCl of that concentration. That it would give off white steamy fumes. Anyways. This gives the H to water. Do you see that happening?
yes.
The H plus is going from HCl to water. And what's the result?
H3O plus
And Cl.
minus.
This is called the conjugate acid. Do you remember that word? Conjugate means acid on the product side. And Cl minus would be the conjugate
Base.
base, which is the new base on the product side. So the acid transfers its H plus to water. So we're saying water is a base because it's receiving the H plus. What about water makes it able to receive H plus? Let me ask the question again. It's not negatively charged. Why does water receive H plus? Lone pairs of electrons. And we've seen this before, back in Unit 2, which you're coming to that Saturday Unit 2 review, right? It was called a dative bond. When H plus goes here, this goes like that, and it becomes this. You remember this? These two electrons would connect with this H plus, and you get this as your result. And we would learn how to do the dot and cross structure for that as well. But what makes a base able to receive able to receive H plus? A lone pair of electrons. So in previous, I probably would have told you, this is a negative charge, because it's easy to look at. And that has to do with the third definition that Cambridge is not good. Yes. A nucleophile is a base. It is. There's college level organic chemistry for you.
The base or acid that's on the.
Product side of club conjugates, which you'll see formally defined very shortly. Take a look at the second example. Hey, that's good buddy NH3. What was that again?
Nitric acid.
No, NH3. I got some. You want me to open it up? Pour it at your table? You're going to be working with it next week.
Okay, then yes. Like,
Yeah.
what do we have to do?
Let us prepare for it now.
Yeah. Let you marinate in it. How about it? I got some extra ammonia here. Y'all want to smell like ammonia, right? Here we go.
Yellow.
It's lemon ammonia. Here we go. Sniff it, but just waft it.
Give it a good whiff.
Don't deep breath it. How's it smell? Look, this is from Publix. You purchased this as a cleaning product, not the reagent grade. I will be giving you reagent grade next week.
So that's like.
This is lower concentration. Just waft it. I told you to waft it. I know that was good.
No reaction. Bro, I gotta slap my eyes.
Waft it. It's not really bad.
If you like look at your nose, it's not that bad.
Take a good whiff.
Waft it.
You're gonna just pass it? Come on, give it a good whiff. Deep breath.
You good?
Yeah, give it a good That's what I'll say. I didn't expect it
I
to be like
still
here.
smell it. I still smell it. I still smell it.
That's an experience, not a smell.
Like, I can't find the clear stuff. I have it reagent grade, but not like from Publix. That's the best I can get from Publix. But it has to smell. Because I smelled it. I already smelled it. She literally said, "Waft it." I said, "Waft it."
You got this? It's long enough for us.
In the instructions.
Yeah. Yeah.
You good? Over here? All right, Katie. Can you shake your head now? You want to walk it? Walk it. You're a fun next to the garden. Wait. You don't have lavender. All right. This is like, you buy this at Publix, it's like $3. Anyway, acidic or basic? We just said Cambridge said it was basic, right? So let's prove it. What is this?
Some script of some
Called litmus paper. Red will turn what color? In base? Blue. Blue basic, right?
shit stuff in my first answer. Ooh, fancy.
Blue. Basic.
That was fast.
Yeah, it's instant. You'll be working with these next week too. Because you're going to be using that to help determine what you have. pH is. Great. Hand sanitizer coming my way. Welcome back. So, NH3 has a wonderful smell like urine. Have you ever smelled like a litter box? It smells like that, doesn't it? You know why? Does this look Alright, let me get your attention. It smells like urine because urine has CONH2. That's the chemical formula, which is a derivative of ammonia. That's why urine smells like ammonia.
Oh.
Because it's related. It's a related molecule.
Oh, that's what I remember with the past.
Yeah. If it's an unclean bathroom. Like when you go to an unclean bathroom, like sometimes it hurts. It is. But it has a very similar smell too. I would never use it as a house cleaner myself, but people do. Yes. Go ahead. No. Stop. All right, so let's go back to what we were learning. Why is NH3 a base? Why is it basic? I've just proved to you that it's basic, haven't I? Theoretically, I'm just putting hand sanitizer in my hand. My God. Let me cry. Why is this a base? Okay. And so, what does it do?
It accepts H.
It accepts pH, right? And if it accepts H plus, it becomes, because it gained an H plus, right? It gained H plus. NH3 turns into NH4 plus when it becomes an acid. That has a fun name, a polyatomic ion. And this is a
Headache, and yet you smell this.
why'd you do that?
Curiosity.
Oh, well, for satisfaction, right back.
That's the whole thing.
This one?
All
Alright, let me get your full attention again. Possibly yes. Does this also fit with the Arrhenius theory? Does the Bronsted-Lowry theory fit with the Arrhenius theory?
Yes.
The Arrhenius theory says that when I have an acid and I put it in water, it's going to produce H plus. HCl, when I put it in water, does it produce H plus? According to this chemical reaction.
Yes.
Yes. Because H plus in water is H3O plus. Whenever you have an acid in water, the H plus always gets transferred to water. So H plus in water is actually always H3O plus. And so yes. And then the base. Does this fit the Arrhenius theory? NH3, when I put it in water, does it release OH minus? It
Yes.
does. It does, because it accepted the H plus from water, therefore releasing an OH minus. Therefore, my pH paper is saying that it's now blue, because it's detecting the OH minus that's now free, right? So that's the idea there. And so what you're going to have to do is you're going to have to look at reactions and possibly create reactions via Bronsted-Lowry theory and determine what's your acid, what's your base, and what's your acid and your base on your product side, which are called conjugates, you'll see shortly. Or, yes, acid 2, base 2, they now call it sometimes. Which of these reactants is your acid? Take a look at the reaction. NH4 plus. And how do we know that? Got a positive charge. Look at its action. It's doing what when it goes from reactants to products?
It's transferring with H plus.
It's transferring the H plus. So it's donating the H plus, which is what an acid does. Which means H2O is acting as a base. After the reaction occurs on the product side, NH3 is now a base. NH3O plus is an acid. It's coming. The double arrows are there on purpose. Because this is going to tie back into equilibrium. It is neutral. It is also amphoteric. Wait. question, but I'm gonna mention it now since you brought it up. I think I have it in Monday's lesson. What is amphoteric? Think of the prefix amp, like amphibian. What do you know about amphibians? Okay, they live. No, you don't know. No animals. What? They live on water or land. So think about water itself. Amphoteric means can be an acid or a. It depends on what it's combined with. If water is combined with an acid, it is a base. If water is combined with a base, it is an acid. Therefore, it is amphoteric because it has the ability to donate H+. It has the ability to also accept H+. Interesting, right? Write that down because it's something you need to know. Do the second example. What's your acid on the reactant side in the second example?
Acid.
It goes from HCOOH to HCOOH.
Wait, so.
Yep. Because it has the ability to give away H+, and it has the lone pair of electrons to
So
accept
if it's on the reactants with the base, it's gonna be an acid. If
Yes.
it's with an acid, it's gonna be.
Yes. What's my acid on my reactant side?
HCl.
HClO2. Because HClO2, if you look at what happens to it, it loses its H+ on the product side. So this is an acid because it's donating to the HCOOH, right? Which means that that's a, yes you go, base. Which means this is what? An acid, and ClO minus 2 is a base. It's important to note that whatever compound is an acid on one side of a reaction becomes a base on the other. And whatever compound is a base on one side becomes an acid on the other. That's how it works. It always switches. You'll notice double arrows. Equilibrium. Comes an extra carbon. Wait a second. No, I'm like looking at that. Like, work out that chemical formula. That was crazy. Conjugates. So I've mentioned this, but I'm going to bring it up again now. The acid and base on your product side have a specific name for them. They're called the conjugates. Conjugate means come from. So the acid that you get on the product side is called the conjugate acid. The base on the product side is called the conjugate base. New terminology that Cambridge is using for this, conjugate acid is also known now as acid 2. Which I actually kind of like that better than what I was talking. What does acid 2 and acid 1 mean? 1 would be on the reactant side and 2 would be on the product side. So your first acid and your first base would be the reactants, and your second acid and your second base would be the acid and base on your product side. And so conjugate acid is also acid 2. Conjugate base is also known as base 2. And so here's a couple other examples of reactions already written out for you. Actually, I think these are the same with the notation. So now, in the next question, you're going to be asked to identify acid 1, base 1, acid 2, base 2 in the next reaction.
So conjugate acid is just named acid.
Product side,
Okay. Just named acid too.
acid 2. That's new terminology from Cambridge. 2020, I think they started that terminology in 2019. So I guess not so new. All right, take a look at this. We actually saw something very similar to this, just they've been swapped around. HClO2, HCOOH, ClO2 minus, HCOOH2 plus. HClO2, we call that acid 1, base 1, acid 2, or base 2. Which one is
Acid
it?
1.
Yes,
Miss Felicia, do you have Hakeem?
I do.
Going home.
Bye.
Do you leave any homework to?
Yes. a beep. That was a beep.
That was a strange beat though.
It was a different beep. Anyway, let's continue. I should mention, on any side of a chemical reaction, there will only be one acid and one. Yes. Hello. Oh.
Just like the push button.
It's not me. All right. There should only be one acid and one base on each side of the reaction. Acid and base reactions operate very similar to redox.
I'll make sure to ask what's going on downstairs.
Okay. Except, and I want to write this out. Redox is a transfer of what? I'm gonna beep them. We'll beep them. They're gonna come on the second. All right. Hello? I think they might have accidentally kept the button pushed and it keeps hello? All right, I think that's it. Anyways, so redox is a transfer of electrons. Agree? One element loses electrons and another one
Gains.
gains. Acid base is a transfer of what?
Hydrogen. Proton.
It's a transfer of protons. Right? One gains and one loses. So aren't redox and acid-base reactions literally almost the same thing, except what is the subatomic particle that's being changed out? They are. They are. And that's why you can either have acid-base titrations, or we could have redox titrations. Because we could either be measuring the H plus transfer, or we could be measuring the electrons transfer. Just FYI. That's why those are the two types of titrations we do. Anyway, thought it was an interesting aside, but an important one because it's actually kind of related. All right, on my product side, what is ClO2 minus? What is that?
Base.
Base 2. And the second one is acid 2. Now you could start on either side. You could figure out the product side first and then go back to the reactants. One strategy that students like to often do is identify this molecule right here, or that ion. That doesn't have any hydrogen, does it? Can it be an acid if it doesn't have H+? It literally cannot. Would you agree? So it has to be a base. So knowing that that has to be a base, and knowing that there can only be one acid end, one base on each side of the reaction, you can figure out everything else.
Yeah.
This is the base, this is the acid, and then this is a base on this side, it was an acid on the other side, right? That's how it works. All right, let's take a look at the one on the bottom. What do you want to start by finding first? Which one?
HS, no, HS minus.
HS is a base.
HS is a
HS minus is a base. Base 2.
is a base acid.
Remember, pure acid and water is H3O+, right? So you could start there. That is pure acid and water, so that has to be an acid.
And H2S is acid 1.
H2S is acid 1, because it makes this base, it loses its H+, and this is base 1. Perfect. Acid 1, base 1, acid 2, and base 2 accomplished. How many marks do you think a conjugate acid, conjugate base question will likely be on a Cambridge test?
1 point.
Bet you it's 1. What other type of question could they ask you? I'm going to tell you about your homework. They could ask you, what is the conjugate acid? Cl minus. What would it be?
HCl.
HCl. So if they ask you for the conjugate acid, they're adding you to throw an H plus on it. If they ask you for the conjugate base, they're asking you to take away an H plus from it. Make sense? So there will be two homework questions. I know I was rewriting it last night that looked like this from a old paper too. It'll either ask what is the conjugate acid, add H plus, or what is the conjugate base, take away H plus. Yes? So conjugate acid means add H plus, and conjugate base means take away H plus and get whatever the result is as your molecule or your compound. All right, we've got another question coming. I think they had just accidentally held on the button is what happened. All right, good to continue? Last question on this. Identify the acid on the right-hand side of this equation, which is conjugate with the base on the left-hand side. So they're just asking you, right-hand side is product, right? What is the acid on the product side here? Perfect. It's just the answer.
And based on the left-hand side would be CH3 and H2.
Correct. Just circle that. That's the answer. They would ask you to like write the chemical formula. All right, moving on. We now went over Bronsted-Lowry theory. Memorize it. You could be asked to memorize definition. A Bronsted-Lowry acid is what?
Acid, an acid that gives H plus.
Gives away H plus donor or proton donor, right? And what is a Bronsted-Lowry base? Accepts proton, accepts H plus. These are definitions that can be asked on your Cambridge exam. I was mentioning to you the other day, I noticed that this class likes to memorize definitions because they seem like easy money points. So that would be some ones you want to grab in because they are definitions that are 1 or 2 points on a Cambridge exam. All right, here we go. Next topic, strong and weak acids and bases. So there's good news and bad news here. The reason I waited so long to teach this topic fully is because the definition for a strong acid is one that breaks apart in water 100%. What does that actually mean? That means, and I'm going to write this but with the Arrhenius theory, if I have HClAQ, there's a single arrow, and I have H plus and Cl minus as my product. When it dissociates 100%. That means for every 1 mole of HCl I have, how many moles of H plus would I have?
1.
1 mole of this and 1 mole of that. Agree? A single indicator is a way to know you have a strong acid. Reaction goes to 100% completion, meaning this all transfers to become this. So a strong acid, you've got to memorize them. There's 3 to memorize. They are the same 3 I told you at the beginning of Unit 3 of this school year. You need to memorize HCl. It breaks apart 100%. And also, if you see HCl in front of you, like in a beaker, like, be careful. It's strong. H2SO4 and HNO3. Now, I can tell you we are instructed on your Cambridge exam to write the words, not the formula, on your paper 3. When you have whatever is labeled in front of you, it will be labeled. And you'll see that when you practice. It'll say hydrochloric acid on the container. It will not say HCl. You're going to be expected to know that it's HCl. I mean, yeah. If you feel like it. You each get your own lab station. Sure. You write it if you want. It makes you feel better. But I'm telling you, they're going to write the full name out on your paper 3. By name, not by formula. All right. So what is the definition of a strong acid? Wait, please wait. Actually, yeah, the test is available. It completely ionizes in water. Whereas a weak acid only partially ionizes in water. What's the difference?
arrow.
Single arrow versus double arrow. And what does double arrow mean?
That could be reversible.
That in this reaction with a weak acid, you'll have some H plus that broke off, but not all of it. So if you had 1 mole of this, you would not have 1 mole of it. Right?
Is 0 point something.
You would have 0 point something mole. And how would you know how to figure it out? You would have to be given an equilibrium constant. And you would need to construct an ice table to figure it out. Right? To figure out the amount. But it's typically less than 10%.
Less than 10%.
Of initial concentration.
Oh, less than 10% is what's called.
Of a weak, it's typically less than 10%, but anything less than 100% is not a strong acid. Yes. Yes. Right, so only about 10% of the H's are breaking off. And you'll see this in something like a carboxylic acid. So like ethanoic acid, CH3, COOH, has double arrows, and you'll get this. You still have the same products, but there's an equilibrium with this. You're only going to break apart about 10% or less of the H plus in the carboxylic acid.
So if we were asked to make a reaction and we didn't put double arrows, would they mark it wrong?
Yes. Exactly. It all links together as you keep studying. Like, there's pieces that all start coming together. And so bases can be strong or weak as well. Strong bases also break apart 100%, whereas weak bases do not break apart completely. A weak base you should be well aware of is ammonia. It's not a strong base, it's a weak, it smells strong, but don't get that confused. It is actually a weak base. If you were to take the pH of it, it'd be around 11. Whereas a strong base is something like NaOH, and its pH is around 14, depending on concentration. NaOH breaks apart all of its OH minuses, 100%. Now, should you memorize your strong bases?
Yes.
You know what they are.
No.
That is right on the right track. So strong bases, you should memorize are your group 1 alkalis. What do I mean by that? LiOH, NaOH, KOH, and I guess the others too. Right? They're all the group 1 alkalis. They probably won't test them, but who knows? They could test you things in the same group, act the same way. Group 1 alkalis. So like LiOH, KOH, NaOH, etc. You also memorize, back in the day, Unit 3, I know not your favorite unit, there was a trend for solubility of hydroxides and solubility of sulfates. Do you remember that trend for group 2?
For group 2?
For group 2. Solubility goes up as you go down the periodic table. Do you remember that? You better restudy it. I don't think it was on the paper too the other day, but it can show up. And I don't think so. But I'm bringing it up as a point. What do we mean by increased solubility? It actually means increased OH minus in water, right? Which means the more I go down the periodic table, the stronger the base will be. There's actually a trend there. So for group 2, your stronger bases will be down the periodic table, not up the periodic table. So I just wanted to bring that up. But your very strong bases are your group 1 alkalis. You can guarantee that all of those break apart 100%.
What do you mean with group 2 break apart 100%?
When you get here around, it gets a little bit confusing. That's why Cambridge just asks you to memorize the trend that solubility increases as you go down, because calcium hydroxide still is a white precipitate. And I probably should be able to show that to you next week. All right, so next week expect a big lab week, like lots of labs all week long. because we got to get through that final type. pH and acidity. We did this already, right? I don't have to tell you this. You know that 7 neutral, less than 7 acid, more than 7 base. Welcome back. Notice a few things here. As you increase the concentration of whatever acid or base you have, the pH changes. If I have the pH of a 1 molarity solution of hydrochloric acid, it has a pH of 0. If I have a 0.01 molarity concentration of hydrochloric acid, it has a pH of 2. Does that make sense? That the higher the concentration of acid, the lower the pH.
Yeah.
So higher concentration acid equal lower pH. Would the same be true for bases in the opposite way?
Opposite.
The higher the concentration of base,
The lower the pH.
of OH minus, sorry,
Oh,
the higher the pH,
yeah.
right? It would be opposite, because pH up past 7 means basic. In this class, you only need to think qualitatively here. In pre-ACE, I actually showed you the formulas. pH equals negative log H plus, all of that stuff. The negative log formula, we did it back in pre-ACE. You are not tested in ACE. It is actually the first topic in A level. So where this class ends, that class begins, pretty much, which is back to acids and bases, but the math. Here you are largely going to avoid the math of acids and bases. But think about it. Double arrows, didn't I say? What do you think the math of acids and bases is? It's equilibrium. That's what it mainly is. It is equilibrium. All right, so let's take a look at this. Nitric acid is strong. HCl is weak. You're being told this. Cambridge is telling you this. They ask you to explain the difference between a strong acid and a weak acid. Can you do that?
Yes.
If the pass is back, you can. Yeah, you can.
A strong acid, like all the H classes are like what's it called, separated, while a weak acid not, all are separated.
Right. We'll break apart all of H plus, whereas a weak acid will only break apart some of them, right? Or you could say will not break apart completely. There'll be some left in the molecule form. And then the second part says write an equation showing the ionization of each of these acids in water. So we're going to show the ionization of nitric acid. And we're going to do chloric 1, HCl.
Oh.
First one, HNO3. You have a decision to make. Single arrow or double arrow.
That's
Meaning
one of the
all
ones
reactants are going to become
that-
products. So H plus, plus,
and then 3 minus.
3, minus. HCl,
Double arrow.
double arrows. Because it's weak. Plus, still the same product though.
And get
And
one
CLO
minus.
minus. AQ. AQ. That's it. And so I would predict if I had the same concentration of each of these solutions, the pH of HNO3 would be significantly lower because it's a stronger acid. All right. I have a question coming up from paper 2. And the first one is a dot and cross. I want to bring up something before I tell you this question. Notice it's a part F. Back in part A, B, C, D, E, F, they actually told you in this question, you may have seen it before, that S is like this. They give you the chemical formula of it, and they tell you it's double bonds only. Use this information, because I'm giving you, this was in part A. This was provided in part A. So they give you this information because otherwise you wouldn't know how to solve it in part A. Using this information, can you do the proper dot and cross diagram for SO2. Try it. That's something we learned earlier this year, right? Do that. Yes. And actually, a few people got counted off on the quarterly because they didn't show all the valence electrons. They only showed what was in the middle. You have to show all the valence electrons. Because it says outer electron. So sulfur and oxygen, right? Get that part? They told you it's double bonds.
Yeah.
That's important. Because if we make a little key, I'm going to do S with circles and O with X's.
Yeah.
You can do it the other way if you want. I know how many valence electrons does sulfur have
6.
and oxygen has?
8. No, 6.
6. If it was 8, it would be a double bond. I know that this has to be like this,
Oh.
don't you?
Oh yeah.
You're told that. They tell you that in the question to have you figure out the rest. If these are two double bonds, what's this up here? I've only taken
Lone
4. It's a lone pair. And that's why it's bent,
Yeah.
because of the lone pair of electrons that is here. They're giving you a clue. There's a lone pair there.
Yes.
This sulfur only has 6 electrons. 1, 2, 3, 4 in the double bond, and then another pair up here at 6. Yes? How many marks do I have right now?
1.
1. No, so far 6. You're 16. Oxygen also has 6, so the others would be here. And then this is 4, right? 2 lone pairs on each oxygen. And that would be in your paper 2, yours was worth 2 marks. 1 for the inner core being correct, and 1 for the rest. In this one, they're being very stingy because they gave you this information earlier in the question. And they said they get this whole thing right, and you get 1 single mark. So, look at what's 2 marks right after. What's a strong acid? Roxylary acid. Can we do that for 2 marks?
It's a donor of H plus.
So, it's a donor of H+, that's 1 mark. Yep, donor of H+, that breaks
Oh yeah, strong.
apart completely, or breaks apart, or dissociates, right?
Yeah.
Completely. That completely word, or some synonym for it, is one of the marks, and the donates H+ is the other mark. That's 2 marks to say that. That's why I said, these definitions, I would know them. Because if it shows up, they're not hard to give the answer. It's not a lot of words you have to say to get a lot of marks, a decent amount of marks. Last one. Oh, this is 2 marks, by the way. Look at this. Another 2 marks. Write an equation to show the acid-base behavior of sulfuric acid with water. Include state symbols. So, sulfuric acid, you would have to first know the chemical formula. Do you know it?
SO4.
H2SO4. With water. So what do we add with it? Plus H2O. It says write an equation to show behavior. They're asking you to show this. These 2 questions are linked. Like how does it donate H+ or receive H+?
Oh, you don't have to stick together.
I haven't done it yet, but I will. What is the next part? Single arrow or single arrow? All right. Now, if I'm showing the behavior, it means I'm showing what sulfuric acid does. What does sulfuric acid do?
Plus HSO4 minus.
Yes, correct. Correct. It donates H+. When you show this equation, you show one at a time. You always show just one transfer of an H+. Yeah, I underlined them. Breaks apart completely is the other one. Like when you put in water, it breaks apart 100% or completely. ionizes completely. There's a bunch of different terms to say it. It would be breaks apart, but not completely. All right. Now what? You're showing a transfer of 1H plus when you show Bronsted-Lowry. They're never more than one. So to be clear here, we just show that this transfers 1H plus. So what would you get? HSO4 and H3O plus. How many marks do I have? One. State symbol. H2SO4, water, HSO4 minus, H3O plus, H2. All right. Someone brought up, I think it was Julio, and it's a good point. Why not both H pluses? H2SO4 is a strong acid, right? Let me tell you something. It breaks off one acid at a time, right? So H2SO4 goes to HSO4 minus plus H plus. That is a strong acid. Once it becomes HSO4 minus, that is not a strong acid. Only the first H plus in H2SO4 is the strong acid. HSO4 minus would, this would be SO4 minus 2 plus H plus would be apic acid and would have a K, it would have an equilibrium constant. So only the first H plus in sulfuric acid is 100% ionization, to be clear. This they're trying to get you by using that as the option instead of HNO3 or HCl. Those would have been easier because they only have one H plus, so you don't have a mistake there. So if you show a transfer of 2 H pluses here, it's not going to be right. Only one. No marks. Not if you transfer both H pluses. 0 marks. Unless you get the states right. Oh. There's 1 mark for states and 1 mark for the formulas. That's how it works. All right, here we go. So we're done with acids and bases at the level you need to know them. We're now talking about nitrogen. Yes. Test their pH with a pH meter. Experimentally. That is it. Otherwise, theoretically. Nitrogen gas. So there's a whole section about nitrogen in this curriculum. It's actually not very long at all. The first thing you've got to know is what the basic information about nitrogen is. Do you know what group of the periodic table nitrogen's in? 15. Is it a metal or a non-metal? What's its standard state?
Gas.
Hold on, wait. N2 gas, right? Because it's a little bit more than 70% of our atmosphere and almost 100% of Mars. Random fun fact for you. It's over 70, so you're breathing in nitrogen all the time. You just don't use it for anything. You breathe it back out when it's gone. Not utilized. You use the oxygen to breathe it, right? But you take in nitrogen, think about it. You're taking in all the molecules that are in the air, right? They go in your respiratory system. Anyway, draw the Lewis structure for nitrogen gas. What that look like?
3 electrons and then 1 lone pair.
So, welcome back. If it's N2, what's its Lewis structure? Don't breathe that in. I think you just passed out though. It's used euthanasia, right? That's nitrogen gas, right? Triple bond. What is the electron configuration? Right? All right, before moving on, note. Nitrogen, I mentioned, I believe, a little while ago, it's extremely unreactive. Can you look at the chemical structure of nitrogen and explain why? one of the things Cambridge wants you to be able to do. It's that triple bond, which means that bond is extremely hard to break. And what's the other reason? It's non-polar, so there's no difference in electronegativity, so the electrons are not moving around, right? So you're not going to have that polarity, that partial positive, partial negative charge that kicks off a bunch of chemical reactions. You're not going to have that. So because it's non-polar, those are the two reasons. It's very unreactive. So you can explain that using info that we've already learned in this class, but that is something that Cambridge wants you to know. And so, I mean, I got ahead. That's the end of it. I was mentioning so stable, right? Triple bond and non-polar. Okay. Interestingly, oxygen has a much lower energy, bond energy than nitrogen, and is reactive. If it wasn't, we wouldn't be alive. Because of oxygen being reactive, we have all of those biochemical processes that need the oxygen we breathe to happen. We do not, and we do not know any living creatures that can utilize nitrogen the same way that we utilize oxygen. So for those of you who want to study life on other planets very far away, that's interesting information. All right. Structure of NH3 and NH4. The next standard. Cambridge wants you to know everything about the chemical structure for NH3 versus NH4. First of all, do you know their names? NH3 is ammonia. NH4 plus is so name. NH3 is ammonia. NH4 plus is ammonium. The next thing they want you to know, Lewis structure. What is the Lewis structure for each of these?
A lone pair with electron and 3 hydrogens for NH3.
So NH3 would be five valence electrons for nitrogen, one valence electron for each hydrogen. Connect the single dots. And what would the Lewis structure for NH4 plus be? Beta bond. And they want you to memorize that. That is NH3, and that's why I call it down for beta, because we just showed this. Or something very similar, that you need that pair of electrons. That H plus is there. What's going to happen? Big bond, right? It's just an arrow, yes. You do not. So I'm just showing how it happens, like from here to there, but it would be NH, like on your questions you'll see very shortly, it'll be like that, right? Next, polar or non-polar? Polarity. Ammonia. Isn't ammonia being dissolved in water here? Like dissolves like. Ammonia is polar. Lone pair of electrons. Electronegativity difference between nitrogen and hydrogen. All right. What about NH4 plus?
Trick question, polar.
Ionic.
What? Part of an ionic compound, isn't it?
Yeah.
The ion.
So it's polar?
It's the ion. Ionic is more. It's gained an H plus. It's an ion. It has an H plus. It's an ion. Just to say. All right. Bond angles.
Oh,
They will test you on bond angles specifically of these two molecules. This is 4 groups where one is a lone pair. That's 107. Pyramidal, yeah. called pyramid. Or pyramidal, like either. And then for ammonia, what's the bond angle? 109.5. And the shape is 4, so it's tetrahedral. Do you remember any of this stuff? They want you to know everything here, pretty much, about ammonia and ammonia.
Why is it?
It's part of an ionic compound.
That has to be a metal.
Cation and anion. I prove you next week in lab. Remind me, because I'll take it out.
Sure.
It's a solvent. It's literally just like, it's actually, I think I showed it to you when we did exothermic endothermic and it got cold. It was the thing that got cold. You poured it in water, you felt it got cold. If not, we'll take a look at it. I have more.
David.
Next week is lab stuff. All right. How do we prepare? What? It can be. It can be used. Usually you use nitrate, like potassium nitrate. All right, let me get your attention. How do we prepare ammonia via acid-base reaction? This is actually an important one for you that you're not familiar with. There's something interesting here. If you have NH4 plus acting as an acid, and then you've got it with OH minus, it makes a specific compound in this double replacement reaction. So you may want to start this from scratch. NH4Cl plus CaOH2. Knowing that this is double replacement, plus minus, plus minus. This is a +1 charge, -1. What's the charge of calcium?
Oh.
+2, right?
+2.
What are my products? What are your predicted products if you were just looking at the classic reaction? You would get NH4, OH, and you would get what? BaCl2. Right? Because the +2 crosses down, right? So, something you need to know. Remember how H2CO3 always breaks apart and you need to memorize this? It shows up on so many exams, including the quarterly last class. Whenever H2CO3 is seen, it breaks apart to water and carbon dioxide. Well, guess what? NH4OH in water breaks apart too. So you should write that down. It becomes NH3 and H2O. This is actually NH4OH dissolved in water, and it's NH3 that you smell. NH3 and H2O. And so Cambridge is asking for you to know this information. If you were to do a double replacement reaction and produce NH4OH, you're actually producing ammonia and water. And so this is a way to produce ammonia. You're going to take advantage of this next week in the lab because you may have a reaction, you produce ammonia, and guess what? You got that little test strip, you put it in and it turns what color? Blue. And that's a way to know that you have ammonium as an unknown. Because when you react it with OH minus, you got the blue color. You're going to be looking at something next week called chemical tests, which, wait a second, doesn't that sound familiar, chemical tests? You did chemical tests for organic. The last thing to learn next week is chemical tests for inorganic, which is like acid-base stuff, like what we're looking at here. Yes?
No sugar balance do we?
Yeah, I didn't balance it yet.
Oh.
So you would then break this apart to NH3 plus H2O plus BaCl2, and then you would have to do what with the equation? Balance it. Which is already being shown to you here. It should be actually 2 of each of these, or sorry, it should be this, it should be, oh wait, this isn't balanced. This should be a 2. This should be a 2, that should be a 2. That should do it. Like that. So this is important information, and this is important information. I will bring this back to your attention next week when we study chemical tests. But what I mentioned here is actually a chemical test, which is why this can show up on not only paper 2, but paper 3. This can show up in paper 3. All right, let's see a paper 1 question. Ammonia can undergo acid-base reaction with hydrogen chloride. It makes ammonium chloride. What statement is correct? Is the ammonium ion basic?
Yes.
Is it?
No.
NH4 plus. Is that a base? Could that ever be a base? Based on what I taught you at the beginning of class today, does this have the ability to be a base?
No.
It does not have the requirement of a lone pair of electrons. It cannot receive an additional H plus.
Yeah.
It is not a base. It's an acid, actually. Notice you're going to read ammonia and you're going to think it's a base. And that's probably what happens. Especially if you're scared on test day or reading questions too quickly. All right, hydrogen atom from HCl donates electrons to nitrogen. So HCl plus NH3 goes to NH4Cl. This is the reaction, right? They're saying hydrogen gives a lone pair of electrons. Does hydrogen have a lone pair of electrons?
Oh, hydrogen. Keep getting me with these. They need to read.
Hydrogen donates something, like H plus is donated, right? H plus is the opposite of a pair of electrons. It's a proton, right? So that's a no. That's the no. No. Definitely not. The bond angle in ammonia is the same as that of ammonium. Is that true?
No.
No, we just looked at that. The answer is D. NH4 is the same as methane. They're both tetrahedral. They're both 109.5. 109.5. No, I just had to prove each of them. So you understood. All right, last real topic of the day. I didn't print it out in color because it's too expensive. But what? It costs like $10 whenever I print your notes out in color, by the way, so you're welcome. Nitrogen cycle. For the following reaction to occur in the air. So what we're talking about here, the last set of standards is talking about how nitrogen oxide is produced naturally and unnaturally. This is the standard. So you've actually already heard how nitrogen oxide is produced unnaturally. It's in car engine. And then you have to get a catalytic converter to remove it. Do you remember that? So how is nitrogen oxide produced naturally? This is something called the nitrogen cycle, which I don't know if you learned this in biology. I don't know the standards. But the nitrogen cycle is basically it starts with nitrogen in the air reacting with oxygen in the air. But you should say, hey, Miss Leeds, the first thing we were supposed to learn is nitrogen's not reactive, right? Nitrogen's not reactive. So we're saying that nitrogen reacts with oxygen. How does that happen? Lightning. That's why that's there. So you need a great input of energy to break that strong triple bond. And so like electricity, lightning, right? So if I were to write something above the arrow, I would write lightning. You need a great amount of activation energy to kickstart that reaction. And what happens is when there's lightning, so a lot of this happens in Florida, doesn't it? You would assume that we get a lot of nutrients. Environmentally speaking, we have the most lightning in Florida, like of any place in the United States. So we get this reaction a lot in our atmosphere. We produce nitrogen monoxide. Hey, wait a second. Nitrogen monoxide, you think that's a stable or an unstable molecule?
Unstable.
Let's draw the Lewis structure. I got enough time, I think. NO, if we draw the Lewis structure, by the way, Nitrogen has 1, 2, 3, 4, 5 valence electrons. Oxygen has 1, 2, 3, 4, 5, 6. You get this. Is that stable? That's what that is, though, right? That's the only way that can work. It has an odd number of electrons. Hey, what's that? What's that? That's a free? Oh, so lightning causes free radicals. Okay. This is chemically speaking, this is what happens. So that's highly reactive in our atmosphere. So it's going to react with something, and that's when we go to the next step. Nitrogen monoxide, because it's highly reactive, will react with an additional oxygen that's also in the air. And it'll make NO2 instead. I'm going to draw NO2 for you real quick. That's NO2. What you notice about that one? It's also a free radical. I mean, it could, but to get rid of that free radical, what do? You combine it with water and a little bit of additional oxygen in the air, and you get HNO3. What? It's a nitrate. And so you get nitric acid. It falls to the earth in rain. And this provides nutrients for plants. Because proteins require nitrogen, right? So nitrates used are produced to make the proteins in your soil. Plants use this nitrogen to make chlorophyll, nucleic acid, DNA, RNA. If you have a nitrogen deficiency, you get stunted growth, yellow leaves. Have you ever noticed when it dries out in the winter that the grass turns yellow? Lack of nitrogen from this process. This is called the nitrogen cycle. It starts with lightning. We usually don't have much of an issue in Florida because we usually have a lot of rain, actually. But this is an issue in various parts of the United States. So if you study environmental management, I'm sure you studied this a lot more. Did you?
We maybe covered it for like a lesson. Mentioned briefly.
Like left? All right. In the atmosphere, these nitrogen oxides can be used when they are produced unnaturally from your car engine. They actually react with SO2 from industry, and it'll convert SO2 into SO3, where NO2 is acting as a catalyst. So when it's produced from car engines and you get additional extra NO2, it reacts with SO2 to make SO3, and that's there, which then re-reacts with oxygen to become NO2. SO3, you're going to see this in the next slide, plus H2O makes what? Combine them. H2, SO4. So when the NO2 from car engines reacts with the SO2 from industry, you make SO3, which reacts with water to make sulfuric acid, which is what we call acid rain. So we're very close to the end. Very close. Hold on. Acid rain. This is not part of the nitrogen cycle. This is additional acid. And remember, sulfuric acid is strong acid. And so because of the pollutants that you get from your car engine and from industry, because of this process, and yes, they could ask you to memorize and write down these equations, so make sure that you are paying attention and you're writing this down in your notes because they do want you to know these. This is the little tiny environmental segment of the class. It's actually not a very large segment, but there's a chance it shows, so you should. And so you can get acid rain, which will eat away at your plants. It'll eat away at your statues because it reacts as an acid does by corroding. And so it has corrosive properties. It'll also lower the pH in your rivers, streams, and lakes, which kills your fishies. Yes. I think it's not enough time. It's 13 and 14. All right, so it is 2:10, and we are pretty much done. I just want to bring up what acid rain is. I don't even see it in the standards anymore, but what it is. And they do still want you to know these reactions and that this leads to acid rain. And so we'll stop here. But I have your tests. I do have your tests. I put the grade threshold, then your test, then the mark scheme, so you can look over it. I'm also staying an hour after school today to help with anything equilibrium-wise. Here you go. Here you go. Turn the page to see your score. It's not on the first page. Diane?
We should always hope everyone has their test and look at their scores.
Oh, you left something? Sorry. Can you turn the picture from the front? That'd be very nice.
So you don't like it.
Not that I can think of off the top of my head. Justin? Why?
I couldn't see that.
Julio? Peter? Yeah. Sophia? David? Wait, you said A. Mariani?
I don't think do the vowels. Show us the vowels.
Roslyn?
Show us the vowels.
Ben? Alex? All vowels. I can write it on.
You're scoring a cheater.
The money said that right as I was looking at it.
You guys have the lady after me, everyone.
Tell me. I'm getting You got one more?
One more than you. I won.
Yeah, but
You got a C. Not very many. This is
One more point for it. God plays up. One more.
So if you said the reaction is
one more.
left of there, that's so good. Yeah. That's it. But if you talk about elements, but it's because it's the very last thing you learn about when you're a lot of people
Ain't no way, bro. Ain't no way.
Yeah, there were a few marks. I mentioned there were a few marks. But I gave you one that had a little bit lower grade threshold to counter that so that it would be as even as possible. Next time you look at a test, we'll tell you this is more. Oh, I love public. There's the first scene in the back.
I got two. 2 marks out of 8.
Can I see?
No one sees so then why don't you show me? Wait, no, we did get 50. What did you get?
You got the end? How do you forget the end? Be 1 more. She gave you 2, but you said 1. You should have my score. You should have my score. You missed 1. Miss. Correct.
Look at this idiot got 15. Me first. I could never.
Mistake. Miss the S.
He will He will not. You want to see my score? Don't tell him. You gotta promise.
Look at them being lenient with you.
I promise.
Yeah, they should be thinking of it. Oh, yeah. Take the marks in the back.
I got.
If you remember the score, you just whisper it.
I
Exactly.
No, show me, David. Okay, show me, David.
I need a pen.
Get up the news line, Emily.
This is Debbie.
Tell me if you got higher or lower. Tell me that. If you got higher or lower. Higher or lower. Higher or lower.
Where the appropriate school units are,
Higher or
our
lower.
must be as follows: red, black, white, online that I have after school on time between 7:10 and 15 a.m. to 1:30. Classes begin at 7 p.m. The rest of this room is in effect for you may only eat lunch in the cafeteria, and the red tables outside are the area. If you bring a bike to school, make sure you bring a lock to school and lock it up.
I got 60 right there.
So now, visit www.sports.com.
Yeah, look at that end.
The art garden
Look at that end. It should be.
Donations are appreciated. The project will take place on Wednesday, April 20th, 24th after school.
I
It
guess.
is mandatory for all members to donate for this.
Students, today is detention day. We had a few that did not serve last Tuesday. We are getting the detention doubled if you did not reconcile that with me. Checking your hero. There should be 8 that are separate as well this afternoon. Please check your hero to confirm your. Students, please be sure that you are checking your dates. Twice a day in the morning and in the afternoon. And we'll be sending all of your testing and Saturday school information through day school. I will not be using CIA Cambridge and Thank you.
How do you get a 20? You know how much?
No, let's get him. You just didn't do anything for this bag?
Yeah.
Come on, 25. But it's better than like. Oh, no, I didn't. I put 7 though. That was my word. 7.
I did like years ago.
I took an estimation for what was in it and that.
David, thank you, Junior. You're not messing with my water bottle. We are not doing that. We're not doing this again. We are not doing this again. We are not doing this again, David.
That's 20 you're going home.
Not nice.
Wow.
Wow. He's mad. At least he did. You're being mean.
We're not doing this again, David. Not again. Don't worry about it. You're not missing
You
it.
guys get to choose your seats. You don't have to sit there.
I would rather sit next to Alex, David.
Since when?
We got 9. We got 9 more. Where?
Just because
Don't
he
they?
showed me like carnal animals.
The rule was in fire. No, Dave. The rule was in fire.
I'm gonna leave myself. Yeah.
Fire.
Because I will
I knew
not.
that thing.
Okay.
Where is
We're
it?
not
Like,
okay?
fire. No, I'm talking about my backpack. Oh, my backpack. I was looking for my backpack. I was looking for my paper. Huh? Your paper. I know.
Oh, I definitely heard that wrong. I was like, you don't want to do this time.
You're staying, right? Yeah. I'm leaving.
It's not at the top of my
Thank
head.
God you're leaving.
Sorry. Have a nice day. Yes, you can take a little break and come back.
Then I need to go to a meeting.
Okay, that's
Oh, I
fine.
also have to go to that same meeting.
I swear to
Goodbye.
God.
What meeting?
Online.
For what? Oh.
Alex, see you.
If you're
Hey,
coming
David.
back, I'll still be here.
David, David, I will actually not talk to you right now. David, you sit down.
You suck? Why? Huh?
He sucks.
Why?
He just does. Trust me. Trust me.
Sure. What color do you need?
red, purple, red or
So a
purple.
color purple, a colored pen, preferably. I just need it back because these are my special pens. Gonna get the thing for the tutoring sheet for the signing in for the tutoring stuff. All right. Yeah. Thank you. Have a good day. All right. Let me get this. I'm gonna do a little thing. Tutoring paper. Oh, I haven't turned this off yet.